Okay, in this video, I'm going to talk about using the law of sines to solve an oblique triangle that is a non-ambiguous case, meaning either angle, side angle, or angle, angle, side. Both of them work very similarly. This is found in section 6.1 of the textbook. Okay, so here is the layout of your basic oblique triangle, and this is the law of sines. For any triangle, the following ratios are equal. The length of side A divided by the sine of angle A. That ratio will be equal to the length of side B divided by the sine of angle B. And that is also equal to the ratio of the length of side C divided by the sine of angle C. You can see that each ratio is made up of a side length and then the sine of the opposite angle. There are three different ratios here. In a problem, you only use two of them at a time, depending on what your given is. Now, this does have an alternate form where all the fractions are written as their reciprocals. And sometimes it's nice to write things in that form. All right, so we'll work one example out. This will need the use of a calculator, a scientific calculator that will work out sine and cosine. So here's a typical problem. As I mentioned before, they usually give you three measurements. This has two angles, angle A and angle C, and then one side, side A. Now, you can sketch a diagram of the triangle if you like. There are times that is very helpful. So here I just drew it out. It can be very hard to draw things to scale, so normally I really would not bother. This one did have an obtuse angle. A is 110 degrees, so I did draw it as an obtuse triangle, but normally you really don't have to worry about it. In fact, you can just make a list of what you know, and what you don't know. So there are three angles and three sides, and you can put in what you do know and then fill in the other ones as you go along. All right, now if you look at this, you can see that you have a nice pair here. You have the measure of angle A and you have the side opposite. And that is a signal that you can use the law of sines. We have angle C, but we don't have its opposite side. So we should work with A and C to get started. So here would be the two ratios that we would do. A divided by the sine of angle A equals C divided by the sine of angle C. And we can put in the three measurements that we do know, okay? We know both the values of A, the lowercase a and the uppercase A, and then we know the uppercase C. All right, so if you put the numbers in, then you are looking at this ratio right here, all right? 7 divided by the sine of 110 degrees is equal to C divided by the sine of 33 degrees. Now, you can just solve this as a regular equation. You're trying to solve for the variable C, so you could multiply both sides by the sine of 33 degrees, since you're dividing by it. That will work. Or you can use the property that when two ratios are equal, the cross products will be equal. So if you multiply 7 and the sine of 33 degrees, that product will equal the product of the sine of 110 degrees and C. So it could be written like that. All right. So, and then when it's written this way, you can see in order to solve for C, you would divide both sides by the sine of 110 degrees. And then you would put the expression on the left into your calculator, all right, and round to whatever the desired number of decimal places will be, all right. I worked this one and did 1 decimal place, all right. Now you do need to remember to make sure your calculator is in the mode for degrees. Okay, so now I have side C. I can go back to what I have here and I can put in that this was 4.1. All right, now I need B. All right, now angle B will be the next easiest thing to get because for any triangle, when you add up the 3 angle measurements, the sum is always 180 degrees. So if we're looking for angle B, you can do 180 and subtract angle A and angle C. So in this case, 180 minus 110 minus 33, and that'll give you that angle B is 37 degrees. Okay, so then back to my master list, I can put that this angle is 37 degrees. All right, and then the last thing to find will be the side B. All right, now I will go back and solve it in a way that I originally approached solving side C. All right, try to work with your given as much as possible because those are exact values and they haven't been rounded. Side C, for example, we rounded 4.1. All right, so I'm going to use the pair angle A and side A to find the missing B value. So in this case, one last thing to do. I'm going to use this ratio for the law of sines. Side B divided by sine of angle B is equal to side A divided by the sine of angle A. And when I put in the 3 numbers that I do know, all right, I need to solve for B. Okay, and again, you can think that the cross products are equal and write that. So B times sine of 110 degrees is equal to 7 times the sine of 37 degrees. And then you can divide both sides by the sine of 110 degrees to solve for B. And B is approximately 4.5. All right, rounded to the nearest 10. All right, and then that is the last thing that we had to find. Okay, so let's go back here. So remember, solving a triangle means to find all the missing measurements.